Hello there. Welcome to our today's science lesson. The topic for the day being chemical formulas for compounds. Mainly in our today's lesson, we are going to review much of what we have been doing in the previous lessons. That is how chemical formulas and their names are normally generated one from the other, because you can generate a chemical formula from a name or a name coming from a formula. So the two are one and the same. However, we also have some few cases whereby you will find that the name and the formula, as much as they are agreeing in terms of the names, but you cannot just point out one-on-one that this is the formula from the name. But going by what we did, we have to review for a better understanding. I will start off by going through a kind of an exercise where we shall be filling in some missing words so that we can catch up with the correct statements as per the formation or the coming up of formulas. Then from there, we shall look at how names and formulas are related to each other, putting in mind that we have three cases. The first case will be a compound that is formed when you have a metallic element combined with an unmetallic element, but they are only having two types of elements in a compound. The second case will be a compound where you have more than two elements in a compound, and that's where you will find some incoherence in terms of the name and the formula, like it will be have seen in the first case where you have only two elements. For that, the coherence will be there, but for the three elements or more, then you will find that there are some areas where connectivities will not come in very well. But that part will be solved by what we shall have seen in terms of the names of the group of atoms that operate as a unit, the ones we call radicals. Then the third one will be a case of naming compounds that have two elements, but the two elements are all nonmetals. Remember, that one will be different from the first one. The first one was a metal and a nonmetal, but the third one will be a nonmetal and a nonmetal, so two nonmetals. The second one can be a metal and a nonmetal, but you may find that maybe you have two nonmetals, one metal, having three or even more elements in one particular formula. So let's go through a kind of an exercise that will help us understand, first of all, some of the statements that we have to use as we cover the other exercises. I will be reading out, leave out the spaces that you are supposed to fill in, which I will assist you to fill as we go on. So the first statement is, most chemical dash have numbers in them as well as the dash for elements. So these are questions that is talking about chemicals. It's talking about most chemical what? We have been talking about chemical formulas. So most chemical formulas, you can see it is even coming from the heading or the title for the day. Most chemical formulas have numbers in them, which is true if you can just pick any of the formulas we covered in our previous lessons. For example, sodium oxide. You will find that in this chemical formula, we are having a number. And this is the number we are talking about. This number 2. It obviously has a meaning why it is placed at that point. To proceed on, so we have most chemical formulas have numbers in them as well as the dash for elements. So in this formula, we have a number already mentioned. What we haven't mentioned is the N, A, and O. What is this? These are letters. So telling us that most chemical formulas have a number and letters in them. Most chemical formulas have a number and letters in them. And each letter and that number will obviously be having a particular meaning, which is specific to a particular chemical formula. The second statement, this dash tell us how many dash of each dash are combined to form one molecule of the dash. So we are still referring to this. The second statement is still referring to this. So going step by step, this dash, so this formula, the dash, the formula, this formula. So what does the formula tell us? So this formula tells us how many, it can be how many elements or how many atoms. An element and an atom is one and the same because an atom is for an element. So this formula will tell us how many elements or how many atoms of each element. So how many atoms? These are atoms of sodium, 2 atoms of sodium. So this formula will tell us how many atoms. Then these atoms must be of a particular thing. So how many atoms of each element? How many atoms of each element? So the element here is now sodium. The atoms are 2, but of which element? Sodium. From the formula. So the formula is telling us how many atoms of which element are, we continue, tells us how many atoms of each element are combined to form one molecule of the compound. So this formula will tell us how many atoms of which element are present to form this formula of this particular compound by the name sodium oxide, just as an example. The third statement is, in addition, some elements dash to form a group of atoms which dash to stay together when the chemical reacts. These are very important statement because it is going to be very helpful when we shall be talking about the second assignment, where we shall be naming a compound that has more than 2 elements in the same compound. So how do we fill in? In addition, some elements react to form. Some elements react to form. So these elements, you can have more than 1 element coming together. So if I can have an element A combining with B or even plus C to give us a particular formula ABC, they are saying that these react to form a group of atoms. These are a group of atoms. As an example, we are taking A, B, C to be atoms. So as they react, these elements, they are reacting. When they react, they form a group of atoms. To complete the statement, before I explain further, a group of atoms which tend to stay. So filling in the space is, these atoms tend to stay together when the chemical reacts. So you'll find that after A, B, C as elements come together to form ABC, it remains that way as a group. And since they are together, they will always operate as a single unit. They tend to be together, operating as a single unit. The atoms, maybe giving a good example of these, not using ABC, we have radicals like nitrates. In this case, we are having 1 atom of nitrogen and 3 atoms of oxygen. Just like as we have said, A, B, C coming together to form ABC as a single unit, a group. So these ones together, they operate as a single unit. Whenever they react as one. That I've already given an answer to the next group, the next statement of a question, but the statement will be radicals. And the ABC here, as a group of atoms acting as one, are called radicals. An example here being nitrate. So we also have another statement, which is the last one. These groups are called, I've already said the name, and the groups here are called radicals. So what does it mean? It means that when 2 or more elements come together in a reaction to form a group of these atoms that will henceforth operate as one, not as 2 or 3 or so on, depending on the number of atoms, then that type of a group of atoms will be called radicals. So these groups are called radicals, and their names are usually used in the naming of the dash which contain them. Their names are used in naming the compounds that contain them. That is a very important statement. As I said earlier, it is going to be very helpful in answering the second assignment we shall be handling, which is a bit unique because it doesn't apply that all cases the name and the formula will be in total agreement, like as we shall be seeing in the first case. So that one being like an eye-opener to our assignment of the 3 questions. Let's look at the first part of the 3 questions. I said the first part is going to include compounds that have only 2 elements in them. 2 elements in them. In these 2 elements, the first one is metallic and the second one is non-metallic. Now, a review of how we did the naming. The name of such a compound, if I can pick on what I've just heard, that is sodium oxide. As the name goes, sodium oxide. Sodium oxide. There are rules that were followed for us to achieve the name. What are the rules? The rules are the first element, which is always the metallic one. The first element, which is always the metallic one. So we have the first element, which is the metallic one, is always assigned its full name. So the full name of this first element in our formula is sodium. As you can see, even the name here is in full, sodium. And it is always metallic. The second name, we take part of the name. When naming the second element, we take part of the name. Remember, the second element here is oxygen. But as you can see from the name, we are not seeing oxygen in full. But we can see part of oxygen, which is this part, ox. So in naming compounds that have only 2 elements, the second element will only take part of the name. Then we add there a suffix IDE. IDE. Can we see it in the name? Yes, it is there. IDE. So that one confirms that the name sodium oxide followed the rules of naming. That is the exercise I would like us to go through. I will give out some formulas. Then from the formulas, we get the name, and let's see if truly the name we know we'll be following the rules, and if you are also able to come up with the correct name, just like as I've seen, as I've shown here, that the formula sodium and oxygen coming together, sodium being a metal, oxygen being an nonmetal. The first element, sodium, carries a full name, sodium. The second element carries part of the name. Here we have ox. Then we complete the second name with a suffix IDE. So here comes the formulas. I will be giving 3 at a time. 3 examples at a time. The first one is KCl, number 1. Number 2, let's have ZnCl2, and number 3, we can have MgS. These are compounds that have only 2 elements in them. Some may appear to have, like now this one, the second one, there's 2 here. You remember in our statement that in our formulas we always have numbers, and those numbers, in addition to letters, speak volume in this formula because they have a meaning. And in our previous lesson I said that these 2 is just but the combining power of zinc. The combining power of zinc here is 2. And the combining power of chlorine here is 1. And being 1, we don't indicate. That's why we haven't indicated here. But if it were more than 1, we could have indicated. So when you see those numbers, it is just an indicator of the combining power of the other element, the other side, because you do a crossing. Whenever you are writing the formula, you cross the combining powers. So let's get the names of these. Follow the rules. Following the rules, first of all, let's check the formula. Is it following the rules by having the metal first, non-metal second? For the first one, K stands for potassium. Cl stands for chlorine. Chlorine is a non-metal. Potassium is a metal. It therefore follows the rules. Let's now get the name. In getting the name, we also have to follow the rules. The rules are the first element carries its full name. So let's have the full name, potassium. That's the full name of the first element. The second element is chlorine. Do we write chlorine in full? Do we write chlorine in full at this point? The answer is no. The rule says take part of the name, then you fill in with a suffix IDE. Now when picking out the portion of the second element's name, you always have also to look at how will it fit in with IDE, because the name that comes out must be having some coherency. You don't just cut at any point and you add in IDE, because one can imagine, for example, that you can take, for example, at this part and you add in You see, reading this name will be difficult. It doesn't bring any sense. So you don't just pick any part. You have to make sure that the parts that you are picking plus IDE gives out a good name. So that's why for this one is at this point. We cut that at point so that we can now have when we add in now IDE is chloride. The IDE. Having taken this one as the only portion for the second element, which is chlorine. So our full name here therefore becomes potassium chloride. giving us our suffix and giving us our portion of the name of the non-metal element in the formula. Let's look at the second example. Zn stands for zinc as a metal. Cl, as you have seen for the first case, stands in for chlorine. Let's still follow the rules as we have done for the potassium chloride. So in this one we shall get zinc. Remember, the first element carries full name, zinc. The second one carries a portion. We have seen for chlorine we take up to R. So we have chlor. Then we fill in with our IDE, giving us zinc chloride. Let's look at our third example, which is now different from the others. I didn't want to use chlorine again. Now here we have our metal being magnesium and the non-metal being sulfur. This is a metal, this is a non-metal. Following the rules, first name magnesium in full. Second name we have it as sulfur. Sulfur. Do we take the whole name? The rules states that we only take part of the name. Then we fill up with the IDE. So which part can be more favorable for us to take a portion? Can I take SU? Let's try and see. SUIDE. That name does not bring any sense. Let's try another one. SULIDE. Salide. It doesn't bring the statement sulfur in the name, because in that name let it sound closer to the original name of the element, and the original name here is sulfur. This one will be salide. Though it brings out some good sense of a name, but now it doesn't relate the salide to the original name, which is sulfur. So that one cannot be allowed. Let's try another one. SLF. Now we add F there, sulfide. And I think that one sounds good, because sulfide as a name sounds good, but again from the name there is that sounding of sulfur, sulfide. Sulfur, sulfide. So there's an agreement. So this gives us now the name as magnesium sulfide. Magnesium sulfide. Having our IDE. Remember I said earlier that you may find some books where a name like sulfur, instead of F, they also use pH. Sulfur. So we can write sulfur as F, using F, but you can also write sulfur using pH, depending on the origin of the books you are using. They are all correct. So those are the three examples. Let's add on some two other examples, then move to our next example, questions, where we shall be having more than 3 elements in a compound. So to add on, let's have 2 more of this kind, where we have only 2 elements in a compound, and we have to name them. Let's have this, that is number 4. Then number 5, where we shall have So I'm looking for those that look a bit more unique so that we can look at them more keenly and feel happy that we have generated the formulas so easily. So let's look at number 4 and number 5. In this one, you can see it has a number here and a number here. That's what I was looking for. At least we have the numbers and appearing in more than one position. So we have a number on the first element and a number on the second element. So how do we name such a compound? First of all, let's identify and see if it is following the rules. Is it metal first and metal second? Yes. Al stands for aluminium. O stands for oxygen. Aluminium is a metal, oxygen is another metal. So that one, it has fulfilled the rule. Let's now name the compound. In naming the compound, the rule states that, number 1, give full name for the first element, which is aluminium. Aluminium. So there we are. Let's look at the second part. The second part is to pick the name of the second element, which is oxygen. So we have our second element as oxygen. Oxygen, we only pick the first part. Remember, at the end, we have to sound like oxygen. But again, the name that we get must be realistically sounding. So when we pick ox, we add here our ox, and we add there our IDE, ox, oxygen. They sound at least closer, but at least again it has fulfilled the rule of having IDE in the name. So this one gives us the name aluminium oxide. Aluminium oxide, as the name goes. Let's look at the last one, and that is Fe and I. This one is I. We have 3 I's and 1 Fe. What is Fe? This one is ion. Ion as a metal. Then I means iodine, which is an nanometal. Remember when we learned about halogens, iodine was named as one of the examples of halogens, where we had fluorine, chlorine, bromine, and iodine. We also mentioned this when we were talking about nanometals that exist in the gases, those that exist in the liquid, and those that exist in solid. So iodine was named in among the nanometals that exist in solid state, which are rare. There are very few that exist in solid state as nanometals. So iodine is one of them. Now, in this compound, we want to get the name. Let's move on. First element, ion. Second, iodine. We pick part of it. Remember, we have to add suffix IDE. We try with this, IO. Then we add in that. No. The best point we can take it is at this point. So that iod, this day will sound to bring in iodine. Then as we add in the IDE, we get io, then died. Iodide. In the name, we have the sounding of iodine, but again, it has followed the rules whereby the first letter, the first element is a metal, the second element is a nanometal, where we just take a portion of it as a suffix IDE. So on your own, you can continue with as many examples as possible, because there are just so many compounds that are only having 2 elements in that formula. Let's now look at our second exercise, which is now going to talk about compounds that have more than 2 elements in them. Maybe it's good we start with an example of a formula, looking at compound like sodium carbonate. That's how it is written. Looking at it, let's identify the elements that are present in this compound. The first element is sodium. The second is carbon, and the third is oxygen. So at least again from this rule, formula, there is a rule that is being followed. The first element must always be a metallic element. Then the others will be nonmetals. However, when it comes to naming, let's try to name. That's not the correct way of naming. Try naming using what we have just used for the first exercise, which was 1, we give the full name of the first element, which will be sodium. Then the second one will be the name of the nonmetal. The nonmetal here we have carbon, we have oxygen. At that point, you become stuck. You can't move on because you have to choose on only one nonmetal. Which one? You can't pick on carbon and leave out oxygen, or pick on oxygen and leave out carbon. So to solve this problem, there is an aspect that we have just mentioned in the preview before the exercise, where we were looking at some statements and filling in some words. We said that we have elements that whenever they react to form a group of atoms that will always now operate as a single unit, and that group of atoms we call them radicals. So in this formula, we are having that type of group of atoms, which we are calling radicals, and that is this part. 1 carbon and 3 oxygens, they always operate as a single unit, a unit we are calling radicals. So it becomes easier by now changing the rules here on naming such compounds. And the rules are, for the second one, which is our third exercise, for this one, name the first element, which is metallic, as we have done it, this one. Then the second part, give the name. You give the name of the radical. In that formula, give the name of the radical. So in all the formulas we are going to look at, the first thing we have to do is identify the metallic element present and the radical present in that formula. After that, we can now come up with the name. Let's try on this one. The first element here is sodium, which is the metallic element. We have done it, sodium. So the second thing we have to do is, let's identify which type of radical is this. And the type of radical in that case is carbonate. So the radical is carbonate. Having identified that the radical is carbonate and the metallic element was sodium, the name therefore becomes sodium carbonate. And it runs all through all compounds of similar formula characteristics. Let's look at 4 more examples of the same kind. You try to get the name, then we shall go through together. So let's have number 2, example number 2. Example number 1 was of this one. So formula number 2 is formula number 3 pick on a different one. Formula number 4, we can have I'm picking on one that has brackets so that we can see how we shall go about it. And formula number 5, you can also look for one that has brackets. Yes, this one. So there we are. We have 5 formulas. And out of these formulas, we can comfortably get the name. Now that it has been simplified, that even if we have more than 3 elements in each, and we need to identify all the 3 elements in all of them as we proceed, it is not difficult to name. Just like we did for the first case, this one is even more easier. You just have to identify the element and the radical. So let's start with the number 2, because we have already covered number 1, which we have gotten as sodium carbonate. So number 2, we have our first element, which is Cu, standing in for copper, and CO3, which is standing in for a radical. Being similar to this, then we can easily know it is as a carbonate. So the radical here is carbonate, and the element is copper. Getting the name, the rule says first name is the metallic element, which is copper. The second part of the name is the name of the radical, which is carbonate. Copper carbonate. Let's look at the third example. That is, first element is Fe, which is standing in for iron, and here we have sulfur as the second element, and the third element is oxygen. Sulfur and oxygen together, they form a radical by the name sulfite. So here we are having iron and sulfite. Sulfite. So the name therefore comes out to be a combination of the metallic element and the radical name. So the metallic element is iron, the radical name is sulfite. Let's look at the next one. The first element is tin, and the second element is oxygen, the third being hydrogen. These oxygen and hydrogen are operating as a group singly, which is by the name hydroxide. So we have tin and hydroxide. Tin and hydroxide. So what will be the name? It becomes tin hydroxide. Tin hydroxide as the full name. Now, using tin hydroxide, there is something we are getting out of it. You don't have always to indicate the number of whatever the number is written on. Like now, this number 2 is affecting everything that is in brackets, meaning that we have 2 oxygen atoms and 2 hydrogen atoms. You don't have to indicate it in the name. Just write the full name of the metallic element and the full name of the radical as tin hydroxide. Let's look at the last example, which is aluminium as the metal element, and the radical here is called nitrite. So the name becomes aluminium nitrite. Nitrate. Aluminium nitrate. We have nitrite and nitrate. Nitrite is written as NO2. This is a nitrite. Nitrite. But ATE is O3. ITE is O2. That's the difference. Still, these are radical and these are radical. You can as well have aluminium nitrite, just like we have aluminium nitrate. So it is as easy as that. Identify the name, the radical, get its name. Identify the metallic element, get its name. Combine the two. You are good to go. You'll have gotten the names of that particular compound. Unfortunately, in this set of compounds, you cannot comfortably use the name to get the correct formula of that particular compound, like the case of the previous exercise we have just done. You can use the name to get the formula of the particular compound. For example, in this case, this 3 has not been indicated in this name. It is just aluminium nitrate. So whenever you are doing the reverse, using the name to get the formula, you have always to remember the combining powers. Very important. Combining powers. They are the ones that will assist you, that will help you get now the correct chemical formula if you have been given a name and you want to get the formula. Maybe let's use aluminium nitrate as an example here. How do I use the combining powers to get now the formula? So I've been given a name, aluminium nitrate, and I want to write its chemical formula. Remember, we are talking about chemical formulas of compounds. That's our point of interest, chemical formulas of compounds. So you have been given a name, aluminium nitrate. Get a chemical formula. How do you go about it? First of all, write the formula of the element and the radical as they appear in the name. Let's do it. Aluminium nitrate. There we are. We have the metallic element, aluminium. We have the radical part, nitrate, because they can never be interfered with any other or confused with any other. It is only one. In the whole world of science, only one thing is called a nitrate, and that is this one. A group of 1 nitrogen and 3 oxygens are the ones we call a nitrate. Will never be confused with any other. Then after that, you now ask yourself, what is the combining power of this type of radical? What is the combining power of this element? We learned that the combining power here of aluminium is 3, and the combining power of nitrate is 1. You just cross-exchange the combining powers, and where you find that the other species or the other reagent, the other part that is forming the formula is a radical, then you enclose in a brackets so that you can indicate the combining power of the other element. But if it is not like here, the case of sodium carbonate, then Na is not a radical. Na stands for one single element, the name being sodium. So for that, you just indicate the combining power of that particular radical. Like now here, 3 is going to the nitrate part, 1 is going to aluminium. So since here is 1, there is no need of indicating. You just leave it. But here we have to indicate because 3 is more than 1. Because of that, we have to put this one into brackets, then indicate the combining power of aluminium outside the brackets as 3. Remember, N and 3 oxygens are operating as 1. So they will be affected by these 3 in the same way. This becomes the formula of aluminium nitrate. Looking at sodium carbonate, the same. The combining power of sodium is 1, combining power of carbonate is 2. In writing the formula, this 2 is because of these 2, where these 2, as the combining of power of carbonate is indicated there, but the carbonate cannot be put in brackets so that we can indicate 1 because it will not have any effect. That is the end of our second assignment or duty on how to name and how to give chemical formulas of compounds. Let's look at the last one, which is number 3, being a bit unique. So the third one is looking at a situation whereby you are having a compound that has 2 elements in its formula, but all the 2 elements are all nonmetals. All the 2 elements are all nonmetals. You also need to remember that you may find that in this case, radicals can also be involved. And where a radical is involved, there will now be more than 2 elements in that particular compound, which is not a problem as we shall be looking at it. You also need to realize that 2 radicals can also combine. In our previous lesson, there is one radical that I mentioned that was a bit special, and that was ammonium as a radical. This is a radical that is the only one that is positive. It behaves like metals, metallic elements. It behaves like metallic elements whenever it is used or involved in a chemical reaction. And like all the other radicals that we have seen, all of those will be reacting or behaving like nonmetals whenever they are involved in a chemical reaction. So we are going to use ammonium as also one of the examples in this case. First, let's start with it. We get a compound that is made up of ammonium so that you can see how we shall be naming that compound. So our first one is ammonium and as a radical and nitrate as a radical. So we are having 2 radicals combined together to form a single compound. Number 2, examples. Among the examples, we can have one of the common compounds we always hear of, CO2. This is a very common compound we always interact with. We can also have this one, which is acid. You can have this one instead of this because it's more common. It's good we look at the common ones. You can also have another one, and number 5, we can have it as P2O3. So let's look at the 5 examples we have and see how we can get their names. Now in naming these, you still follow the first rule, the rule we did in the first exercise, where we said that where we have only 2 elements present, and if they are not elements, then 2 radicals present, and if they are not all 2 radicals, the 1 element and the radical. So we still have just 2. Whether it is a element radical, radical and radical, or element and element, we still talk about 2 cases. Then the rule was stating that the first name is for the first element. If there are radicals, it will be for the first radical. The second name will be the second element, but in this case we have to indicate the number of the second element present in the formula, the number. For example, looking at this, the number of the second element. The second element in this formula is oxygen. How many are we having? There are 2. So you have to indicate the number of the second element in that particular compound. So that is the only part that is different from the first case we saw. In the first case, we were not indicating the number of the second element. But in this one, you have to indicate the number of the second element, and that is if it is an element, not a radical. If the second element, if the second part is an element and not a radical. So let's try and name this. Starting with number 1. Identifying the parts. The first part is the ammonium, which is a radical. The second part is the nitrate, which is also a radical. The rule states full name, ammonium. The name for the first part. Add the second part, which is the nitrate. And you are good to go. That is the full name of this compound. It may be having so many elements because, as you can see, there is 1, 2, 3. 3 different elements present. But these 3 are put in 2. The first part being ammonium as 1 unit radical, and the second part being nitrate as 1 part radical, giving us ammonium nitrate. Let's look at the second part. The second example, we have 2 elements here, that is carbon and oxygen. In naming, we have the first element carrying full name, that is carbon. But now, remember we have said that the second element, if it is an element, not a radical, if it is an element. In our case here, our second part is an element by the name oxygen. Oxygen. Do we have to write the second name in full as oxygen so that it reads carbon, oxygen? The answer is no. We have to remember that we were having a suffix IDE in naming. So we only take a portion of that name, which is OX. Just like we did for the first case. We take part of the name of the second element, then we fill in with the IDE. But still, there's another case we have to solve, and the case is to do with these 2. It is showing that this second element, it is not 1, there are 2 of them. So we have to include the 2 in the name. And the 2 is written using the format I gave earlier in the previous lessons of naming, where we said 1 is mono, di, tri, tetra, penta, and so on until you reach 10, which is a deca. So from what I've just given out, 2 means di. So you can have carbon, di, then fill in the name ox for oxygen, then IDE as a rule, giving our name as carbon dioxide. Carbon dioxide as a name. Let's look at our third example. This is a very important compound or substance in our life. When you have a vehicle and you have that battery which always ignites that engine, this is the substance that is normally found there by the name we are now to get. We have to get the name of this particular substance. Now, this substance is categorized into 2. It's categorized into 2, the first part being this part of hydrogen, and the second part is the whole of this. Even if it is having 2 elements, that is S and O, S standing in for sulfur and O standing in for oxygen, these 2 elements form one unit, a unit we call a radical by the name sulfate, by the name sulfate. So, as the rule says, take the first part in full, take the first part in full, and that part is hydrogen. Then add the second part. Fortunate enough, it is not an element. So being a radical, you just carry the whole name and put it there. If it were an element, then we have to follow the rules by taking part of it, then we add IDE. This is a radical, so the whole of it by the name sulfate, hydrogen sulfate. Hydrogen sulfate. Now, being that it is a solution, hydrogen sulfate will always be carried that way if it is in a gaseous state. But when you put it in solution, it dissolves, then we call it sulfuric acid. We call it sulfuric acid because of now being in solution form. But if it is taken the way it is, it's just called hydrogen sulfate, following the rule. But you dissolve it in water, it now becomes sulfuric acid, which is very important. Now let's look at the last two. The first name is hydrogen. The second name is sulfur. The element is sulfur, but being an element, we go back to the rules. The rules are take part of the name, add IDE. So sulfur, we take that part, then we fill in with the IDE, giving us hydrogen sulfide. Hydrogen sulfide is the name. Then our last example is we identify the elements. P stands in for phosphorus and O stands in for oxygen. So the first element carries full name, phosphorus. Phosphorus. The second name is oxygen. We don't write oxygen in full because it's not a radical, it's an element. So we follow the rules. The rules are take part, ox, then fill in with the IDE, giving us phosphorus oxide. Phosphorus oxide. So essentially in our today's lesson, we have been giving ourselves a summary of how to name chemical compounds that are carrying a different number of elements in them, and again how you can get even that chemical formula from the name. Remember that this is the language of science, whereby you will find instead of using names, formulas will be used in some cases, and we always need to know the correct formula for a particular name or the correct name for a particular formula. That marks the end of our lesson today. Until next time, thank you.